and the energy efficiency it could possibly bring. The next speaker is Mr. Vivek Gilani, the Director of Sea Balance Solutions Hub, who's going to talk about energy efficiency initiatives in the RAC sector. The floor is yours.
Thank you, Philip. In light of the fact that a lot of people have actually already talked about energy efficiency in great detail in the previous session, I took the liberty to actually perhaps stimulate a discourse about a relatively untouched area of how we can generate energy efficiency or negawatts and also lower F-gas emissions from India through beginning of pipe interventions. The basic premise here is this, that an air conditioner is an apology for a badly designed building, right? We're trying to figure out why are these buildings even being designed? What's the supply line of this kind of real estate look like, and how can we plug it at the beginning of the pipe? So the talk is titled Equitable Thermal Comfort for All, because this is also a human rights issue, the access to thermal comfort. Everybody deserves this, especially in these summers where we are comfortable, but outside, you know the situation. And the idea is that can we live without F-gases in our pipes of air conditioning systems by going to the beginning of the pipe of where this unsustainable build space is coming from, all right? So I've tried to classify my talk using Rob Hopkins, the founder of Transition Towns Movements. He has a great way of communicating where before you get into the hands of anything, let's get our heads and our hearts in the right place. All right, so let's talk about some of the intellectual facts that set the context for the interventions that the program that I'm representing, of which I'm the co-founder for air conditioning. Then we'll talk about some elements of responsibility and ethics as to why we need to act in this specific way. And then we could talk about some of the beginning of pipe interventions that we have already been piloting in India for the last 3 years. All right, so let's start with the head. This is a very important context setter. Mr. Akra just mentioned the same fact that the AC trumps all the energy consumption in a building. About 70% of all energy consumption in most residential and commercial buildings is from an AC. So it is where the story is. It's where the battle is being fought. Another very important fact of India's challenges with cooling are actually represented in this really great analysis that Alliance for Energy Efficient Economy has done as part of the work that we are doing in the Smart and Sustainable Space Cooling Alliance, where I think even CSE is part of it. This chart here shows you how few Indian cities, Mumbai and Delhi, if you multiply the population with the cooling degree days, which indicates the severity of the cooling need, we are far more in need of cooling than any other part of the world, actually, which is still consuming high amounts of air conditioning. So you can see Delhi and Mumbai, for example, consume or have a greater cooling need than any other city in China or in the US. So our country is where this battle needs to be fought very, very efficiently, and we need to address these challenges. Couple this with the fact that while we are going to be cooling our country to address these cooling degree days with the populations, that is going to have an outcome of doubling our air conditioning stock every 6 to 7 years. So if you were to look at air conditioners in India, it would look in a petri dish like a virus that's multiplying and doubling its quantity every 6 to 7 years. This is an analysis we did with CEW. So that's pretty staggering. And another fact that is also coupled with this issue is the fact that in India right now, there are about 423 well-known architecture colleges, which only 25% of which offer anything to do with the environmental design or responsiveness of a building. And from those 25% colleges, sorry, only 5% of the courses deal with the issues that we are talking about here. So while we are the converted, right now there are architecture students who are being graduated by the droves, through a pipeline, essentially, without the sensitivity, without the empathy, and without the skills, right? So we're going to address this in some of the interventions, but this is a very sobering fact. Another issue that we've become painfully aware of is that in a typical mechanical engineering, refrigeration, and air conditioning course in India, the only two technologies that students learn about are vapor compression refrigeration, which is an age-old technology, and to some degree in some colleges, evaporative cooling or ammonia vapor absorption. But they are completely deficient in terms of understanding passive cooling methods and understanding other sustainable cooling technologies, including natural refrigerants. Most mechanical engineering students who graduate from a typical Indian college do not know much about natural refrigerants. They do not know much about radiant cooling, structure cooling, indirect evaporative cooling. It's a big lacunae which we need to address. What this leads to is this, that in 2015, in India's 423 architecture colleges, every year we are graduating 17,000 students with deficient skills in designing responsible buildings. And what this will lead to, everybody knows what this will lead to. We've been talking about these figures. Essentially, if AC emissions from India by 2030 will require, if we do nothing, 1.35 billion trees to be planted every year to sequester that much carbon, which is, of course, not doable once the cat is out of the bag. So we have to do this through design and through changing mindsets and approaches. So that's the environmental facts and figures. With respect to responsibility, there's a couple of very compelling arguments to be made. One is that architecture in India has graduated to the state where you do not have a client asking for two options when it comes to structural safety or asking for options with fire safety, that one building is cheap, but it is structurally unsafe, and there's another building that is a little expensive but structurally safe. This option is not on the table. But one of the most important issues that our global community is facing, the biggest crisis hinges on the hobbies of a few builder developers who are interested in looking at the sustainable option. So we need to make it on par with the other safety issues that buildings regularly deal with very successfully right now. Right? It should not be an option on the table. And here's another ethical issue. If you look at these two pictures, I have a quick question for the room here. Which of the two buildings here are likely to have a higher cooling load? The one on the left or the one on the right? Most people would say the one on the right, right? But it is also likely to be the one that will apply for and achieve a green rating. So there is this issue that green ratings are actually for buildings that first challenge and rupture its relationship with sustainability and then addresses it through technological interventions. And what we've started seeing is that this has created a sense that green buildings are actually another apology for badly designed buildings through technology. So what we've started hearing from a lot of green building consultants, young green building consultants, have started saying that green building certification now has acquired this reputation of being largely a paperwork exercise by green building consultants. I think even CSE has written a lot about this. And another sobering fact that we'd like to highlight is that a typical split AC in India consumes enough energy to provide energy for 25 ceiling fans. And what that means is that 41 million AC users in India right now are depriving 25 times that number of people with even the basic access to energy for thermal comfort. Right? So this sets the context for our interventions, and we'll talk about them. So the first intervention that we made was to first understand the supply line or the network that is creating these unsustainable buildings. So essentially our goal is to address commercial enterprises, right? As in commercial buildings as well as residential buildings that consume a lot of air conditioning. And what we realized was they are creating a demand for cooling, but that demand is being satisfied through poorly trained professors, through poorly trained students, through poorly trained architects and HVAC consultants. So this program that I'm going to talk about for a couple of minutes addresses these stakeholders directly through capacity building so that these organizations have a compelling reason to behave differently. All right. So the simplified version of that supply line is that students essentially enter professional practice, and they then serve and support this need for F-gas-based, energy-intensive HVAC systems. And our interventions are designed to address the student skill gap and the professional practice skill gap so that we can implement these technical solutions. I think the solution's already there. But today, even if we had ECBC mandated in all the states, do we have the skills to be able to do this, cool roofs, building design, adaptive thermal comfort in all these ECBC compliant states? We do not right now. All right, so let's talk a little bit about this academic curricula integration work. What we're trying to do in this program is we're trying to give structure and space, which are the two main concerns of an architect, have sustainability be an equal pillar in this conversation, right? So that it should not be a third pillar which is given secondary treatment. So let's look at what we do in these architecture training workshops. What we're trying to do here is we're trying to train the professors of architecture colleges to change the curricula while remaining in the rubrics of the mandates by the Ministry of Human Resources. So can we change the curricula without violating any existing laws and rules? So in these programs, we actually have a 5-day workshop where we cover principles of building physics, passive design techniques. We teach professors principles of sustainable cooling fundamentals. And then we actually get into the pedagogy techniques required for this new kind of design. Traditional pedagogy methods are very classroom-based, are very two-dimensional, they're not interactive, they're not learner-centric, they're teaching-centric. And we're trying to even change this. And we're trying to support them with very creative teaching aids to make this whole process kinetic, make it tactile. And finally, we do a mock syllabus renaissance, as we call it, where we propose to the college, these are some of the courses in which you can make a transformation, right? Okay. We do a similar thing with engineering students, but the approach is a little different. We go straight to the students here, rather than go to the professors, and we are embedding in them the same sort of skills that we talked about. In addition to that, though, we are working with ISHRE and a few other partners in India to teach students, by default, building energy modeling, building heat load modeling, and also ways in which they can model some of these sustainable cooling technologies so that they have the skill when they graduate. All right, and we certify them as well. The underpinnings of this approach is that the curricula in any college defines only a bare minimum. A lot of professors hide behind this, that we can't change things. In fact, a curricula only supplies the bare minimum guideline. You can go well beyond that. We are trying to create integrative versus additive change. A lot of colleges in India right now just have a course called environmental architecture, and they sort of outsource any environmental knowledge into that one course. What we're trying to do is we're trying to change every course a little bit so that sustainability in building design is integrated in everything, including even humanities courses. We're trying to achieve invisible integration. We don't even believe that students need to know that they are learning sustainability as a separate compartmentalized thing. We're doing training of trainer versus student training in most cases. We're trying to create horizontal integration across disciplines in a college. We are trying to embed learning-centric pedagogy versus teacher-centric, and to encourage this whole building design approach when they become professional practitioners. We are trying to create collaboration between engineering and architecture colleges in each city so that they do joint projects rather than get into turf battles when they become professional practitioners. Because everybody knows about this turf battle between HVAC consultants and architects. Right, so that's what we're doing with students. We're doing something similar with architects, but I don't want to take too much time. These are some of the metrics for the program that we've been running for about 2 years now and 1 more year to go. We're trying to integrate sustainability in about 30 architecture colleges in India as part of our evidence-based policy-making work. We're trying to change curricula in 12 colleges, engineering colleges, and affect these many students. And we're trying to embed and default sustainability in these many firms of HVAC and architecture in India so that it's not a value addition, it is a value. These are just some interesting images I thought I'd leave you with. These are some of the teaching aids we're building. Right now, if you ask most architecture students what happens to hot air in a building, they'll tell you it rises. But they have no way to visualize this and actually feel what this really means. So these are some of the teaching aids we're building with architects and innovators in Delhi, for example, to show how in a building with chimneys, you can simulate wind movements using, for example, these small little candles. This is the kind of training we are trying to impart to teachers to bring this in. This is another small experiment which shows you when you have a building with small windows on the leeward side, as it's called, you get much more air velocity. Sorry, you get much more air velocity in this case when you have big windows here versus a small window here. And if you reverse it, you get much less wind velocity. So these are principles of building design which have been converted into teaching aids. All right? So this is the kind of work we've been doing.